Welcome back as we continue with Lee's Session 2 R&D on a custom train system inside of Unity. So what are we going to do in this video, Lee?
Well, in this video, we're going to look at a different way of removing the patches.
Okay.
As you started alluding to in some of the last videos about, well, why not just keep a list of patches that need to be updated? It was kind of funny because that's what I do with patches that need to be removed.
Mm-hmm.
I I didn't do it with the patches that are being updated because I was also dealing with patches being updated inside of the sculpt tool. So it just turned out to be easier where I was just iterating through all the patches looking for anything that was flagged as dirty to be
Okay.
changed. But we are going to be using that type of technique for the patches that we're removing. So because of that, we actually need to create a new list just to hold that information. So if we scroll up to here, let's go ahead and create a private list. Whoa, that is not the list I was looking for. I know what that means. So list, let's enter, and I want generic collection of list. So we're making a list that holds train patch. And we're going to name this one patches to remove. Again, highly descriptive. And we'll set this to be a new list and save that. Now, we have to do some modifications inside the handle train update. Right now, we are iterating through all of our patches, every single loop, checking distances and determining when those need to be done. As been pointed out before, this isn't the most optimal way of doing it. So what we're going to do is copy this, which is, well, actually, let's copy this part, which is kind of the meat of what's going on here. We're going to come up here to when we determine whether or not we've, whether or not we've gotten to a condition where we're scrolling the map. This will be the point where we're going to need to look and see if we should be removing some patches. So we'll do for each. Hey, it finally worked. So we're going to look for train patches in patches to remove. Now, come on. Whew. That one was lagged for real.
Yeah, I saw it.
I'm not crazy. Well, I am, but all right. So if we've got patches to remove, we're going to, for each patch, we're going to do that same check that we did before. Okay, this is making this hard. I'll get it. All right. Actually, I don't need this part. What I do need is some training on formatting. But no, seriously, what we're going to do is we're going to do the same conditional check that we did before. We're basically checking to see if any patches are greater than our tile size count in distance away from our current patch location in either X or Z. But because we're using vector 2s, we're using Y. If that is the case, we also want to do a check to make sure that our patches to remove does not contain the terrain patch that we're trying to get rid of. Because we only want the patch to be in there once. No point in adding it a second time. So patches to remove dot add train patches. So that will add train patches to that list. So this is building our list of things that we have to deal with later. Now, when do we deal with it? Well, we deal with it when we would have done the conditional checks every single time. Luckily, we can do it slightly differently now. We can go if patches to remove dot count is greater than 0, then we can go ahead and check for things to remove. Let's go ahead and tap that in. So we're going to iterate through, instead of train patch count, we're going to be looking at patches to remove count. And instead of train.patches, this is going to be patches to remove. We can look for that. So that fixes all the errors there. We still want to do a conditional check. Now, the reason I want to do this is, for some reason, let's say we backtrack. If you've played with this at any point up to now, if you've actually coded along with us and you're now just getting to this video, you may have very well noticed that if you start running around in the world and you bounce around in circles around an area where patches are being added and removed, patches are being added and they're being removed multiple times. So what ends up happening is you're removing some patches and then you walk back and it starts adding the patches that you flagged to be removed, and you get overlap. So eventually, if you're really adamant about it, you can put holes inside of your terrain that just show up based off on the order of which patches are being removed, and you walked back and it was still removing patches that should have been redrawn. So what this is doing is looking at those patches as it gets to that point and make sure that you haven't backtracked and that those patches shouldn't be removed anymore. Conversely, we're going to have to do the same thing with patches that are being added. We don't want to add, or if we're adding patches that are on the list to remove, we want to remove those patches from the list of patches to be removed and use the patches that are already there. There's no point in recreating patches that you're just reusing. So if they're still in memory, just reuse them. And we will get to that in a later video. I just wanted to try to explain that now.
Okay.
Hopefully that worked. All right, so we also need to make sure that that we're checking our patch update timer. So we want to make sure that it is less than or equal to 0. Oops. And that our distance checks are still valid. Again, this is the same reason we don't want to delete more than one patch at a time. So we're allowed to add a patch and remove a single patch in an update, but we don't, or as soon as one happens, we want to reset the timer. If we happen to fall through, it's not that big of a deal. I don't think you possibly can, but if it were, adding and removing a single patch in a single frame isn't the end of the world. But we don't want to remove all the patches at once. We don't want to add all the patches at once. So that's what we're trying to prevent at that point. From here, we're going to do all the normal stuff, which is destroy the patch, increment the asset sweep counter like before. We have to reset our patch update timer to equal our patch update delay. So once we remove one, we're going to reset that timer. And we also have to remove the patches from the list. So I'll remove train patch. So that will remove it from the list, because we don't want to try to remove it more than once. That probably won't end well for us. So, and then again, we've got our check that says that if the asset sweep counter has gone greater than our tile size count, +2 or ×2 +1, then go ahead and unload resources. Now, if you wanted to really optimize this on your own, the best time to do this would be to modify your character controller and look for a time where the character controller hasn't moved for a while. So if the character has been sitting there and the person is only moving the camera, or even better, the camera hasn't moved at all, basically set an idle flag and then tell this to reset the unload use assets when this asset sweep counter is greater than and the character is idle. That way you won't ever notice the glitch that happens when you're unloading all those unused assets. Just kind of a little trick that you could do, but we're not going to do it here. So then from here, we also want to break out of it, because once we've done this, we don't want it to loop through and do this for every single patch. So if I build that, that should sequence the removal of patches. And if we try, how noticeable was the 1 second delay?
Noticeable as in...
Should I up the patch update delay to make it more noticeable, or was 1 second enough?
I was able to see it, but if you want to, go ahead and make it 2 seconds.
Okay.
Recording at 10 frames a second, that might be a little more helpful in making it obvious.
Right. Well, with the lag on the video, I didn't see any of it because,
Right.
you know, I'm only getting a frame every 5 seconds or so. But I just wanted to make it easier for our
people to see.
Yep.
All right, let's see, which way am I running? How about that way? Yeah.
And apparently it's not removing anything.
Yeah, it doesn't look like it. Yeah, and the only time I'm feeling that little glitch is just on the creation, basically. That first one of the lot that we actually see come in. Then after that, it's nice and smooth.
Right, because what's happening is it's creating all of those patches.
Correct.
As opposed to the multi-threaded solution, which each one of those patches gets handed off to a different thread in a pool of threads, which smooths that all out. But we've got to figure out why we're not removing patches anymore.
And I'm going to do this. Let me just hit pause and let you look through it just so we'll save on video time.
Okay, no problem.
One. All right, so we're now back, and as Lee said, what is it, about 6 o'clock in the morning your time?
5:30.
No, it's 5:30. It's not that bad.
It's not that bad.
So he's allowed to make a few mistakes here and there.
Yep. That's what I was thinking. It's like going, mistakes are good. They, good for the soul, especially debugging, keeps you sharp. But we were looking at this, and it kind of dawned on me when I went over this that if I was looking for my train patch inside of patches to remove, and then comparing those for patches to remove, I probably are not going to get very far.
Right.
So let's change this to, let's say, something that's actually got information I need, like train patch.patches. But in the course of all that troubleshooting, we tested it and goes, yeah, great, we got it. But then we realized that all the patches were still being destroyed all at the same time. I forgot to break out the logic, so to speak. So we need to check to make sure patch update timer is less than 0 and either this condition is met or this condition is not met.
Right.
Not that this condition is met and this condition is met or this condition is met. So yeah, at 5:30 in the morning, little braces like that or brackets, parentheses, whatever they're called, can be overlooked.
Oh, it's all good, Lee. You're doing great.
So we've got that. That should work if you want to test it out.
Sure.
And it should also point out a nice little thing that we get as far as sequencing of when things get added and what things get destroyed and when that happens. which is kind
Right.
of why we do things in the order we do in the train update handler.
So we should see add, remove, remove, remove.
Right. Because if you
Two
think about it,
seconds.
when you're running through the world, it is most important to get those new patches in first.
Right.
The patches behind them, yeah, we can remove them. It's important to remove them, but it's not as important to get those removed
At one,
as it is get the train
two,
in front of the player first.
three, remove, remove, remove. And let's do it one more time. So again, 2 seconds as soon as it begins off the first. One, two, three, remove, remove, remove. Fantastic. All right, let's go, for the sake of testing stuff. Wait a minute.
Or just running around in the world because you like doing it. Because it is fun.
I can't tell which way I'm running. There we go. I think that looks right. One, two, three. One, two.
Oh!
Something looks a little wonky.
What?
Should
What
should
looks.
should it let us get that close? Like,
Well, you got to remember, we've got a large time gap in there just to get.
yeah, that's true. That's true. A big 2 second monster. Yeah, that's true.
Yeah, you don't. Oh, and also you got to remember, we're running on a very small world with a very large delay in the time that you're drawing the patches. But if you've noticed, as you're running diagonal and you're bringing in patches at a different angle,
Uh huh.
it's still queuing up the patches to remove. So it comes back and cleans them up
Mm-hmm.
in the order that they were flagged to be removed. So even if you're running around, you can get some really weird shapes to the train, but it will eventually catch up and clean it up. Now, the cool thing with the multi-threading that you get is this allows you to spin things off onto different threads, and the glitches that you feel now virtually go away. And even this system, when you build out and you set the uh, the patch update delay to something more realistic, like half of a second or a
Mm-hmm.
full second, with a larger world, you won't notice it in a standalone. You definitely feel it more in the editor than you do once you build it
And
out.
especially right now with us recording and connected into my machine from where you're at and the editor running, yeah, we're stressing the machine quite a bit.
Right. And there's one other thing that I'd like to point out. You will still get a hit because when we're adding these patches right here, when any one of these conditions are met, we're adding these patches. If you look at it down here, we're looping through all of these patches and doing all the math for all the patches in a single frame. We're not splitting those up. We're splitting up the moment they get put into the world, and we do the mesh associations, which is also a hit. We're splitting up the calculation hit from the mesh creation hit. But if you wanted to really fine tune this and split it up as much as you can, it would be best to make some sort of queue that you could add these in and then schedule them and then only send off the construction of a patch once every so many or like half a second or a quarter of a second or once a second, whatever worked best for your system. So what you're doing is you're splitting up not only the creation of the mesh, but you're also splitting off and scheduling all of the calculation for each mesh. So now you're only doing one one mesh calculation, one mesh update, and one mesh delete inside of a single frame. And if you start spreading those out as much as you can, you'll smooth out those little glitches a lot more than what we have even here in the R&D.
Right. But again, once built in a standalone, I mean, we've had much slower machines around here running it, and you don't feel it at all.
Right.
Okay.
It,
I'm sorry, go ahead.
I was going to say it does a really good job, but it is well, it's not perfectly optimal. It is optimized, but there's always more that you can do with it.
Oh yeah, I see several things we could do, but we'll play with that a little bit later. All right, so does that pretty much wrap it up for this video?
For this video, we have to come back in the next video and we have to fix all of these methods because we're dealing with the patches to remove. And if you remember, I said, well, what happens if you've got patches that are scheduled to be removed and we turn around and we go back to that area and we need to create them again? There's no point in creating that same patch a second time. Why not just, pull it off of the patches to be removed list, keep that one and not create a new patch. So we're just going to reuse those same patches, which also helps with optimization.
Excellent. All right, well, with that, that is going to wrap up this video. Thanks a lot.